So today we are going to learn solve linear system. And we have learned how to solve linear system by using substitution method. And today we are going to learn a new method. So before we learn the new method, we are going to do a review of substitution method. So solve linear system, it means we have two lines. Then solving linear system means we are going to look for the point of intersection. And for the substitution method, you are going to write one of the equation as y equals or x equals. So isolate x or y. Then we are going to substitute this x or y into another equation to get rid of one variable. In one equation, we want to have only one variable. If you have two variables in one equation, we don't know how to solve it. We need to use the method to reduce the variable number to 1. Then we are able to solve one variable in one equation. So we are going to do the review. Example 1, solve the following linear systems. So we said that we need to write one of the equation in y equals or x equals, and for the equation 1 we have y equals already. Then we are going to substitute the y, equation 1, into the second equation. Okay, so substitution, it means if you could box y, so we want to replace the y in the second equation with the equivalent 3x minus negative 3x minus 2. So we are going to do the sub. So substitution, you are going to have to substitute. So substitute equation 1 into equation 2. The reason for it is we want to get rid of the variable y in the second equation. So we are going to have 5x minus 2. Then the y, we are going to use its equivalent to replace it. So y equals negative 3x minus 2. We are going to put negative 3x minus 2 here. Then equals negative 18. Then you will see we have only one variable left. Then we know how to solve this linear equation. In order to solve this linear equation, we need to get rid of the bracket. The reason for it is inside the bracket, we cannot collect the like terms. Get rid of the bracket, then we can collect the like terms. So we are going to have 5x, then minus 2 times minus 3 give you positive 6. X, negative 2 times negative 2 give you positive 4. Equals negative 18. Then we collect the like terms, 5x, 6x, and move the 4 to other side. Plus 4, move to other side, opposite operation will be minus 4. Then you will have 11x equals negative 22. Then we want to isolate x, so means x equals y equals. We want to isolate x and y. We need to move the 11 to other side. So 11 times x, 11 move to other side, do the opposite operation. So divided 11 means 11x divided by 11, and also the right side, negative 22 divided by 11. 11 divided by 11 is 1, so 1x equals negative 22 divided by 11 give you negative 2. Then we have the x value, we need to find the y value. So continue. We sub. So substitution, you need to have two sub. So one is sub one variable equivalent into another equation to get rid of that variable. Then another step is you have solved one variable, you need to find another variable by substitute this x equals -2 into equation, the isolated. Sub x equals -2 into equation 1 because y is solved, is isolated. So substitute this into equation 1, you will have replace x with -2. Then, so replace the x with -2. This is called substitution. Then we do the calculation by math. Multiplication first. -3 times -2 give you 6. 6 minus 2 give you 4. Then we are going to write the statement. Therefore, the point of intersection is x first, y second is alphabetical order. This is the x coordinate, y coordinate of the point of intersection. This is what we have done before, okay? So it means two lines, the point of intersection is -2, 4 is this point. So then we are going to practice on another one before we start the new method, okay? So this one, 4x minus y equals -3, 2y minus 6 equals 8x. Equation 1, equation 2, and from these two equations, we don't have x equal or y equal. We don't have x or y isolated. We need to find which variable we are going to isolate in which equation. And the hint is look for the number at front of the variable is 1 or -1. Okay, so for this one, x number at front is 4, this one is -1. This is 2, this is 8. So we want to isolate the number at front of the variable is 1. The reason is when we isolate 8, we need to divide the number at front to other side. If you have 4 to 8, it means you need to divide it 4 to other side, divide by 2 to other side, or divide by 8 to other side in order to isolate that variable. We don't want to divide the number to other side because it will have fractions. We don't want to deal with fractions. That is the reason we want to find the number at front is 1 or -1. Number at the front of the variable is 1 or -1 because we divided 1 or divide by -1 to other side, you won't have fractions. So we are going to isolate. So isolate y in equation 1. The reason is 1 or -1 at front of that variable. So we move the 4x to other side. It will be -4x. So you have -3 minus 4x. And we want to have x or y by itself. We don't want to have the -1 at front. So this is a common mistake. Please divide the -1 to both sides to get rid of the -1 at front of the y. Then y equals -1 divided by -1 give you +1. So 1y equals -3 divided by -1 give you +3. -4 divided by -1 give you +4x. This is equation 3. Then we are going to substitution. We do the sub first time. Sub equation 3 into the different equation. From equation 1 to get equation 3, then you need to sub equation 3 into equation 2. The reason for that is if you sub equation 3 into equation 1, it means you are substitute it into the same line. Then you will have the infinite number of solutions, because the point of intersection is all the lines on these two lines. These two lines are same line. So substitute into equation 2, we are going to box y, so we are going to get rid of this y, box it and kick it out. So 2, then the equivalent is 3 plus 4x, so kick the y out, kick the box out. Then minus 6 equals 8x. You will see you have only one variable in this equation, then get rid of the bracket. So 2 times 3 give you 6, 2 times 4 give you 8x. Minus 6 equals 8x. Then we are going to move the 8x to other side. You will see minus 8x. 6 minus 6 is 0, 8x minus 8x is 0. And if you have 0 equals 0, we know it's always true. It doesn't matter what the x value is. You have x equals 1, it works. X equals 2, it works. So this one means it's the same line. These two equations, they represent the same line. They overlap. Then all the points on this line will satisfy these two equations. So we are going to say the point of intersections are points on the line. All the points on the line. So the two lines are same. So infinite, you have infinite number of solutions. Number of solutions. So any points on the lines will be a solution. Will satisfy these two equations. Okay. So these two equations, if you isolate another one, you will have y equals 3 plus 4x from the second one. So that's the reason they are the same line. So if you have the same line, then the point of intersections will be all the points on the line. So you have infinite numbers of solutions. So this is for this review. Have seen two cases. One is we have done many times before. You have two lines, then you have one point of intersections, and just now we have one is you have line 1 and you have line 2, and these two lines, they are same. Then you will have infinite number of solutions. All the points on the line are point of intersections, so infinite point of intersections. And also we have another case, that is line 1 is here, and line 2 is here. And these two lines are parallel, so it means they are never ever going to intersect with each other, so there's a 0 point of intersections. And when you solve the equation, for example, this type of equation, you will have, so this one I will rewrite it, is 0 point of intersection. So you have 0 point of intersection. And when you solve it, you will see you have 1 equals 0. Something like this. So this one will never ever happen. So never equal. Then we know you don't have any xy value can satisfy y equals 0. So we are not going to have any point of intersection. So 3 cases. The first one is just normal case that we had solved before. You have 1 point of intersection, and the second case is the 2 lines are overlap, they are same. And third case is 2 lines are parallel. Then you will see after simplify you have 1 equals 0. It will never ever happen, and you don't have any point of intersection. So this is a review of the substitution. For substitution, it means you are going to isolate one of the variable, then you box it. You box that variable in another equation, then you kick this boxed variable out. Okay, kick them out, then you will have only one variable left. So y is gone, then you have only x left. Then one equation, you have one variable, we can solve it. So now we are going to see the new method. Why we want to have introduce a new method? Because in this equation, you will see the number at front of each variable. None of them is 1. So it doesn't matter which one you are going to solve, you may have the fractions. So we are going to see x number at front of x is 4, 3. Y, the number at front of y is -2 and -5. So none of them are 1. So then we want to use this elimination method. Elimination method is a method that we are going to find the common, the multiplier, the least multiplier, that we are going to change the number at front of one variable. They are same, then we can subtract to get rid of it. So we could do the eliminate y, or we could eliminate x. So we change them to same, then we subtract, then the x will be gone. Or the y, we change both of them to -10, then subtract -10 from -10, it will be gone. Then only x left. This is our idea behind it is we want to get rid of one variable. How to get rid of one variable? We want to change the number at front of one variable to be same, then subtract to get rid of them. So if we want to focus on the x variable, we want to change the 4 and the 3 to the same number by times a number to give them same. So we could 4 times 3, then 3 times 4. Then you will have both 12. When we times one equation, the x with 3, we need to make sure all the terms in that equation we are going to times by 3. Okay, so our idea is we are going to change the number at front of one variable same. So number at the front of one variable same. The reason why we want to do it, because once they are same, we could subtract then that variable will be gone. So elimination means we are going to eliminate one variable, get rid of one variable from the two equations. So get rid of one variable. This is our thought what we want to do. And how are we going to do is we change the number at front of one variable same. And how we change it times equation 1, equation 2 by different numbers. Then after we change it, you will have the variable at a number at one front of one variable will be same. Okay, times different number to equation 1, equation 2 to make them same. Then after that, we are going to add or subtract. If the two numbers are same, then we subtract. If it's opposite, then we add. So this is what we are going to do for elimination. So now we know that we want to eliminate x, then we need to change the 4 and 3 to be same by times 3 to each term in the first equation and times 4 to each term in the second equation. Okay, so we label it. This is equation 1, this is equation 2. Then we are going to see we want to change the equation 1 times by 3. Then each term times by 3. So 3 times 4x give you 12x. 3 times negative 2y give you 6y. And 3 times 6 give you 18. So you must remember times each term. Don't forget any term. Then equation 2 times by 4. You will see 4 times 3 give you 12. 4 times negative 5 give you negative 20. 4 times 1 give you 4. So we label it equation 3, equation 4. Then because we have these two are same, then if they are same, we subtract. So equation 3 minus equation 4. Okay, equation 3 minus equation 4, so we are going to minus bracket. Then we are going to do 12x minus 12x give you 0x. This is what we want. Then the x is gone. We get rid of one variable, and the negative 6y minus negative 20y. So I will rewrite it. Negative 6y plus 20y. Then equals 18 minus 4. Then we collect the like terms. Negative 6y plus 20y will give you 14y. Then 18 minus 4 give you 14. Then in order to solve for y, we want to isolate y. We move the 14 to other side. Will be opposite operation is division. So 14y divided by 4. 14 give you y. 14 divided by 14 give you 1. Then after that, we are looking for the point of intersection. So we want to sub y equals y 1. So we only do one sub. Substitution we do twice. Do substitution twice. And this one, elimination is adding, subtracting once, and sub once. So y equals 1 into, you just pick one equation to sub in. So we may sub in equation 1, okay? It doesn't matter which one you are going to sub in, it will give you the same answer, okay? Then we are going to 4x minus 2 bracket, replace y with 1 equals 6. Then we want to solve for x, so we move the 2 times 1 is minus 2, to other side is plus 2. We have 8. Then we move the 4 to other side by doing opposite operation, then you will have x equals 2. Then therefore, the point of intersection is 2, 1. That is done. So this is called elimination method, and what we have done is we times equation 1, equation 2 with different numbers. Sometimes you may just times one equation with one number, then you could change the number at front of one variable, same. Then after that, if the one variable, the number at front, they are same, then you subtract. If they are opposite, then we add. Then we are going to get rid of one variable. You have only one variable in one equation left. Then we can solve it. It's linear equation. After you solve for one variable, you need to sub that variable back to one of the equation to solve for another variable. Then you are going to have the point of intersection. So this is called elimination method. So you know how to solve this too. You can cover this part and redo this question to see if you are able to solve it correctly, okay? And now you have learned the two methods for solving linear equation, linear system. Now we are going to apply them to see where are we going to use solving linear system in real world, okay? So this one is word problem. For word problem, this is a linear system. We have two equations, so it's different from the quadratic equation. We need two variables. For two equations, we need two variables. For one equation, we need one variable. So some question you could use one variable to set up equation, but we want to practice with solving linear system, so we want you to introduce two variables. So example 1, spot check sells Nike and New Balance shoes. The Nike shoes cost $82 and the New Balance cost $95 each. So we call them unit price. One day they sold 75 pairs of shoes and made 6,241. It asks you how many of each shoes were sold, okay? So we are going to, based on the question, we are going to introduce the two variable. You could write let n equals number of Nike shoes sold, and let, okay, New Balance, I will just use B, equals number of New Balance shoes sold. So let N represent the number of Nike shoes sold. Let B represent the number of New Balance shoes sold. And we have the unit price here. We have the total numbers. So if we have the total numbers, we want to write the total numbers on the other side, the total profit to the other side. Okay, so now you are going to write two equations. One is based on the number of shoes, and another one is based on the dollar, the value of the shoes. Okay, this is number of shoes, this is value of the shoes. And you have N Nike shoes, B New Balance shoes, and altogether is 75 shoes. So it's N plus B. They are not involving any dollars. So it's just number plus give you the number of shoes. And this is in dollars, so we need to find. You have N pairs of Nike shoes. One pair is $82. So the value for the Nike shoes will be the unit price times the quantity. It will give you the value of the Nike shoes. And for the New Balance shoes, the value for that one will be the unit price times quantity. Then you have the two equations. And for these two equations, this is a linear system. We could use a substitution method, but because we just learned the elimination method, so we want to use elimination method. So for this one, we are going to see the variable N. The number at front is 182. And for the variable B, the number at front is 195. So we want to change one of them to be same. You could pick one of it. So you could pick the B, but we still, we may change. We want to eliminate B. Okay, this time we want to eliminate B. Then we want to change these two numbers to be same by times two number or one number to change them to be same. So 195. It will be easier just times 1 by 95. Then you have 95. So we don't need to times two times numbers to both equation. We could just times to one equation. Then we are able to get the same number at front of one variable. Then if they are same, we are going to subtract. Okay. So for this one, it will be 95 times the first equation. Then you will be able to have the number at front of B same. So equation 1 times by 95, you will have 95N plus 95 times each term, 95B equals 95 times 75. This is equation 3. Then we are going to see this one, 95B, they are same. We are going to subtract. Then 95 minus 95 will give you 0. So equation 2 minus equation 3. Equation 2 minus equation 3, then it will be 82N minus 95N, then equals 95 times 75. We are going to do the calculation. So we are going to times 95 by 75. You will have 7,125. Then we are going to continue. 82 minus 95 give you negative 13. Then this minus 6241, then give it negative, will be negative 884. Then in order to solve for n, we need to get rid of the negative 13. Then negative 13 divided by negative 13 give you 1n. Then 884 divided by 13 give you 68. So 68 pairs of neck shoes. Then we are going to have one substitution. We need to find the b value. So sub n equals 68 into, you have 4 equations. So substitute n equals 68 into which equation? 3 equation. Okay, 3 equation. Which one will be easier for you to solve for b? So equation 1 will be easier. So into equation 1, you will have replace the n with 68, then plus b equals 75. In order to solve for b, we move the 68 to other side. Doing opposite operation. Then b equals 75 minus 68 give you 7. Then we write a statement. "68 pairs of neck shoes was sold." And 7 pairs of New Balance shoes were sold. So then that is done. So go back and check. What we did is we introduced the 2 variables, then write the equation for one for number, one for dollars. So for number, we don't have dollars. You need to make sure the units are correct. Okay, the units are correct. And for the dollars, we are going to include the unit price. Unit price times quantity give you the value of that shoes, and plus another unit price times quantity give you the value for another brand shoes. Then add together give you the total value of the shoes. Then we choose the elimination method. We want to get rid of the b. Then we need to times the equation 1 with 95. Then you will have 95b here. Because they are same, we do the subtraction. So we subtract accordingly the n like terms put together, the constant term put together. 95 minus 95 is 0b is gone. So this is why we want to make the number at front of one variable same. Then we can get rid of it. Then we are going to have one equation with one variable. Then we are able to solve it. And don't forget, for elimination, you have one substitution in order to find another variable. Okay, so this is for the word problem. Now we are going to see the example 2. The length of a rectangle is 4 centimeters less than 3 times its width. The perimeter is 64 centimeters. What's the length and width? So we could sketch it. Length and width. It asks you for the length and width. You could just use L and W as a variable. Okay, and the length of the rectangle is, so length is, we are going to translate this sentence into a sentence in mathematics. It will be an equation. So length is L, is 4 less. 4 less means minus 4. Less means subtract. 3 times width, multiplication. This is a first sentence converted to a sentence in math. It will be an equation, and the perimeter is 64. So A's are B, they are equal sign, okay, in math. So perimeter, we are going to see the perimeter for this one. Perimeter is a distance around a figure, so it's just a L plus W plus L plus W is the perimeter. Now we have the two equations, so we just rewrite it here. Let L equals the length, and let W equals the width. And please try some of the full solution for your word problem, because once we back to normal, then paper pencil work, this counting for communication marks, so you need to write it formally. So the first equation will be the length equals 4 centimeters less than 3 times width. This is equation 1. And the equation 2 is 64 centimeters for the perimeter, so 2L plus 2W. This is equation 2. And now you could pick elimination or substitution for this question. And for this one, we are going to see one variable is isolated already. If one variable is isolated, then we could use a substitution method. We box one variable, then kick it out. So use the equivalent to replace the L, the boxed variable. So substitution method, we need to sub twice. So we do the first time sub equation 1 into equation 2. So we kick the variable inside the box out. So it will be 2, then L is out, use the equivalent to replace the L. They are equal. So plus 2W equals 64. So 2 times 3W minus 4 plus 2W equals 64. Then in order to solve this one, we are going to expand, get rid of the bracket. Then we are going to have Then we are going to collect the like terms and also move the -8 to other side by doing opposite operation. So 6W plus 2W give you 8W. 64 plus 8 give you 72. In order to solve for the W, we are going to move the 8 to other side. Then we do the division. 8 divided by 8 is 1. 1W equals 72 divided by 8 give you 9. Then we know that the width is 9. We are going to solve for the length. We do another sum. We could substitute W equals 9 into equation 1 or equation 2, but because equation 1, the L is isolated, so we are going to sub W equals 9 into equation 1, then we can find the L value easily. So sub W equals 9 into equation 1, then we are going to have L equals 3 times 9 minus 4. 3 times 9 give you 27. 27 minus 4 give you 23. Then we are going to write a statement. The length is 23 centimeter and the width is 9 centimeter. You could sub it back to check. So 3 times 9 minus 4 give you 23. Yes, 23 equals 23. It's correct. And the next one, 2 times 23 is 46. Plus 2 times 9 is 18. 46 plus 18, it is 64. So it's correct. Then you could cover this answer part and redo this question and check if you can get the length and width correctly. Okay. Then example 3. So yesterday Mrs. Smith went to Tim's and bought 3 coffees and 2 donuts, which cost her $8.75. Today she bought 1 coffee and 2 donuts, which cost, so cost could be the equal sign again. How much is 1 donut and 1 coffee? So now we are going to let D equals price of 1 donut, the unit price. And let C equals price of a cup of coffee. So C equals price of 1 coffee, D equals price of 1 donut. Then we know that the cost could be the equal sign. So one cost is $8.75, another one is $4.25. Then we are going to use this one, unit price times quantity, to get the cost for each types of the food. So unit price times quantity. Okay. So 3 coffee, it will be 3 times C. Unit price times quantity 3 plus unit price is D times quantity 2. That is the first equation, and for second equation is 1 coffee plus 2 donuts. 2 times donut unit price give you the cost of the donuts. So this is equation 1, this is equation 2. And for this linear system, you could use substitution. Then you move the 2D to other side, then you isolate C, then you take the C out, then you have D left. Or we could use elimination, because you see the number at the front of the variable D, they are same. If one variable they are same, then it's better to use an elimination method, because if they are same, we could subtract, then we can get rid of it. So minus. We don't need to times any numbers, they are same already. So equation 1 subtract equation 2. Then you will have 3C minus 1C. 2D minus 2D is 0D. We don't need to write it. $8.75 minus 4.25. Then collect the like terms. So 3C minus 1C give you 2C, $8.75 minus $4.25 give you $4.50. Then in order to solve for C, we move 2 to other side. By doing the opposite operation, division, then we have 1C equals $2.25. This is unit price for 1 coffee. Then we need to find the price for 1 donut. You could substitute this C value into equation 1 or equation 2. So equation 2 seems easier, so we are going to sub. So sub C equals $2.25 into equation 2. Replace C with $2.25. 1 times $2.25, they are same, so you don't need to write a 1 at the front. Then in order to solve for D, we need to move the number to other side. By doing opposite operation. You will have 2D equals $2. Then move the 2 to other side. D equals $1. Then therefore, write a statement. Write the statement. Therefore, 1 coffee is $2.25. And one donut is $1. Then it's done.